So, anyway, so our penultimate reaction type we're looking at today is, what did I say this was? 2.4? Oh, sorry, no cursive. I got excited there for a second. Now, I think single displacement reactions are kind of sad. They make me feel lonely by proxy. You know, you watch some poor element that, had a partner, had a nice stable bond that it had made with some other element, and then you watch it get, just kind of sadly ripped away from that. But I think double displacement reactions are kind of a happier version of this. Maybe still a little weird, maybe not socially acceptable, but a little happier. So if we kind of revisit our, our idea of last time, what if we had Gary, and Gary's on a date with Mary, and then over here we have Larry and Chad again. Should we get Chad in there again? Yeah, we like Chad. So we have Gary, Mary, Larry, and no, I like Chad. I will come to Bill later, I guess, but I'm feeling good about Chad.
Chad is a strong name.
Right? That's what I'm saying. When I used to be a bartender, I worked with this girl Amy, and she and I used to have a lot of fun. But one of the things we would always do is just give people names, and then usually when people pay, they give you the credit card, right? So usually when somebody pays, you can see how you did and see if you got the name right. And every once in a while, you'd nail it. But I remember she would fall back on Chad maybe a little more often than she should have. But one time she decided a guy's name was Chad, and then when he paid the bill, his name was Chad, and we were very excited. That's the end of my story. All right. So anyway, let's imagine that Gary and Mary have come to my bar, and they're sitting there and they're having a nice cocktail and maybe sharing a nacho platter. I don't know. And Larry and Chad show up, and they're sitting at the bar and drinking a nice cocktail, and they're sharing I don't know. Both order a steak dinner. And Larry and Mary get chatting because they're kind of sitting next to each other. Maybe Gary had to go to the bathroom. Maybe Chad had to go, I don't know, check his stock portfolio or something. And they get chatting. And what do they discover? They discover a shared interest in Peruvian ichthyology and Byzantine.
Pictures online.
Whoa, okay. Listen, I've settle down there, Roost. I'm just telling you what happened. That isn't a judgment call. God. Oh, yeah, well, that's a different discussion. Listen, I take no responsibility for anything Wyatt says, and nor will I ever. But what happens by the end of this date? Well, I don't know if they cheat. Maybe they all agree. Maybe they all just sit down and say, you know what, on further discovery. Yeah, they switch partners. By the end of the night, there you have Larry discovering that he's all this time, what he was waiting for was Mary. Right? Now they're a pair. And then, on the other hand, we have Gary and Chad. And Gary and Chad, they're getting along great. Turns out they have a shared interest in, I don't know, MMA, and what else is somebody named Chad interested in? Nickelback, I don't know. Anyway, right? That guy's name's Chad, isn't it? Chad Kroger. But that's the basic idea. In a double displacement reaction, no, now I'm curious. Go.
No. I'm just like, Mary and Gary, they actually wanted
Hello.
partners already, so they decided to make them jealous.
Oh, I see. It's like a Disney movie. This is like the Olsen twins are making this happen somehow. That might be a reference too old for you, but anyway. Sting operation. I like it. So in a double displacement reaction, two compounds react by swapping partners. We are handwritten here, my friend, so I'm going to grab a piece of paper. Well, no. That's not what we're going to do. I'll get you some lined paper. We can put that in. should ask. Do I have some pencil and paper? I have both pencils.
So,
and paper.
like, say in like a real life situation, like, say like lead would be the ugliest.
Oh,
Well,
okay. We're gonna focus on why, but thank you. So, as in single displacement, and is everyone okay if I just do SD for single displacement?
Yeah.
Good. The pairings will still have a cation, which that's a term we haven't used too often, but remind me, a cation is just a positively charged ion. And does anyone remember what we call the negatively charged ions? Very good. And I'm just going to make a note here. You still have to work out the formula of each pairing. Shut up, phone.
Maybe it's Chad.
Oh, don't tell my wife. I still have to work out the pairing of each pairing. No single displacement or double displacement reactions for this guy. I'm in a stable compound, and I'd like to keep it that way.
I don't know why Barry took Larry back though, because he left her.
I'm gonna feel bad if your like wife like sees this recording.
Yeah, looks at the YouTube.
and just like hears me say that.
Okay. Can we look at an example? Like a real example? All right, example 1, we're going to look at a nice, easy one. And we're going to do silver chloride. You okay? And sodium carbonate. And the first thing we're going to discover in these is that, and I'm going to put a little note here, these are almost always done with everything dissolved in water. And I'm going to put a word here that we've used, but somebody just remind me how we say that. Aqueous, very good. And remind me, what's aqueous mean? Dissolved in water. It comes from the same root as what? Well, or what is its root? It's a Latin word meaning water. Aqua, that's right. Which is where we get agua in Spanish, or agua in Italian, or aqua in French. We use the Old English word water, which comes from the Germanic like Vater. But yeah, anyway. Okay, so silver chloride. Again, we have to work out the formula. What is silver? What's its symbol? It's a weirdo. Ag. And if you check the periodic table that I gave you on like the last test or whatever, you'll see that Ag always gives away 1 electron. It's not one of these multivalent metals. I don't have to call this silver 1 chloride. It always gives 1. And chlorine is Cl. How many electrons does it want to get? Yeah, 1 more. So how do I show that? Cl -1. And do I even need to draw the table? Probably not, but I'm gonna. The first silver will give away 1 electron. The first chlorine will take 1 electron. What's the formula for silver chloride? Very good. And you guys are good. All right, sodium carbonate. What's the formula for sodium? Na. How many electrons does it want to give away? 1. Good. Carbonate, you'd have to check that radical. Does anyone remember it? How do we know it's a radical, first of all? How do I know I have to look it up? Why isn't it just C? 8. 8 tells us it's a radical. That's right, 8 or 8, very good. And if you look it up, you're going to see it's CO3, and you're going to see it doesn't want to get 1 electron, it wants to get 2. So we say CO3 -2. So the first sodium will give away 1 electron, but the first carbonate's going to try to take 2. Is that a pairing that works? What do I need? Another sodium. So the second sodium now will give away 2, and that does work. So how many sodiums in sodium carbonate? 2. How many carbonates in sodium carbonate? So what's the formula? Na. Very good. And I could put brackets around it and put a 1, but then who would make fun of me? Trush. Trush would make fun of me. He'd be like, look at that idiot. That hurt my feelings, so we don't want to do that. Okay, there we go. Okay, well, maybe not to me. My feelings, don't I get to decide if they're relevant? So what's going to swap with what here? What's going to switch places with what? Silver was in a compound with chlorine. On the other side, what's it going to be in a compound with? Silver swaps partners with what? Yeah, with sodium, because remember, you still have to have a positive charge ending up with a negative charge. So we couldn't end up with silver sodium-ide because they both want to do what with electrons? Give them away. You need something that's going to take them. So silver swaps partners with sodium, which means on this side, you're going to have silver what? Silver isn't with chloride anymore. It's going to be silver carbonate. Good. And we'll have to figure out the formula for that. So can I just assume it's going to be AgCO3? I got to work it out. So what charge does silver take? Always? And again, you can look it up. It's not an easy one. It's in the weird middle of the periodic table. But if you go look it up, it always gives away 1 electron. What's carbonate again? And how many electrons does it like to take? 2. So if we have 1 of each, how many electrons did silver give away? And carbonate took? Does that work? What do we need?
So it'd be like Ag2 and then
Very good. So it'd be Ag2CO3. And then what's the other compound pairing? What's sodium end up with now? Sodium was with carbonate. Now it's going to be with chlorine. So that'll give us sodium chloride. And that one, you probably know the formula, but Na takes what charge? +1. It wants to give 1 electron away. Chlorine wants to take an electron. Just 1, right? If you look at where it is. So the first sodium gives away an electron. The first chlorine takes an electron. Does that work? So what's the formula? NaCl. And the good news is we're done and complete, and that question is finished, and we can move on. I think it is. Pretty confident it is. I'll remind you that I'm a chemistry teacher. I teach this for a living. Tatiana Baskerville agrees with me. Just say yes, just say yes. Just, oh, God, you suck. Fine, what do I need to do? Yeah, I got to look at the... You got to go back to school, Orlando. Idiot. Yeah, let's look at the left side and the right side. Yeah, you bet. 100%. Okay, let's take a look at these. What do I have to count? I guess I can count silver first. How many silvers on the left side?
1.
How many silvers on the right side?
2.
Do I just fix that now? How do I fix that now?
Just add a 2 to the AgCl.
Good. Oh, like this.
No.
Well, I mean, that would fix it. Can we all agree? Why can't I do that? Why can't I do that? Well, I can't because 2 Ags don't react with 1 chlorine, right? How many Ags react with 1 chlorine? It's 1 to 1, right? So if I did this, it wouldn't work because that would be 2 electrons given away to 1 taken. So yeah, I got to put the 2 in front. We have to count. So that means I'm not going to have 1 silver. I'm going to have 2. Okay. So far, so good. What's next? Well, let's just keep going. Next, I have chlorine. How many do I have on the left now? How many chlorines? There's 1 here, but how many of these do I have now? So I have a total of? No. Just every AgCl has one chlorine, but how many of those do I have? For a total of 2. Don't overthink it, right? You've got one nose, I've got one nose, so if you put us in the room together, how many noses are in the room? 2 noses. That's right. Okay, on the right side here, how many Ags? How many Ags? 2. Is that good? Looks good to me. Oh, sorry, we're doing CLs. On the right side here, how many CLs? 1. Oh no, that's not good. Should we just fix it? What do I need to do? Put 2 in front of NaCl. So let's do that. We'll put 2 here. That changes that to 2, and that's good now. Let's keep going. How many sodiums on the left side? 2. And how many sodiums on this side? And how many carbonates on the left?
16 sodium atoms walked into a bar, followed by Batman.
That was good. That's good. I like that. I like that one. That one. Normally I don't encourage you on those, Mr. Kelford, but I liked that one. That made me happy. How many carbonates on the left? 1. And how many carbonates altogether on the right? And so we're good. All right. So there's our balanced chemical equation. Do you see the steps we did there? I want you to just pause and think. There's a lot going on, actually, right? In this case especially, I gave you the names. So we have to take the names and turn them into formulas, which I have to build the little chart for, right? I can't just assume it'll be one of each. I've got to figure the formula out, right? And then I had to figure out what the 2 products would be, which I did by saying, okay, if silver had been with chlorine, when they switch partners, silver is now going to be with carbonate. And then I had to figure out the formula, which I did how? By building a stupid little table and working it out. And then I said, well, now sodium's going to be with chlorine, and I had to figure the formula out of that. How did I do that? By building a stupid little table and doing it. You see how I said, like, that skill we learned in Unit 1 we're going to keep plugging away at? Oh, I am. Every day. You can do this so many friggin' times it'll make your head spin.
Well, I mean, like, some tables were, like, unnecessary.
Sure. Hey, listen, everyone's comfort level is different, which means you will sometimes get to a question where you're like, I don't need to draw a table for that. I can just do that in my head. Take your time. The whole thing. So if I wanted to, I could say how many carbons, and I'd say there's 1 carbon here and 1 carbon there. And I could say how many oxygens, oh, there's 3 there and 3 there. But since CO3 is its own thing, right, where if we had 2 of them, we'd like put a bracket around it and say we have 2 of the whole thing. Since it's its whole thing, we can just say, well, how many of these do I have? Does that make sense? And so over here I have, so what this actually looks like, you don't have to know this, but it looks like this. That's what the carbonate ion is. So if you want to, you can count it as a carbon and 3 oxygens and just make your balancing longer. Usually, if it doesn't change, if it's carbonate and it stays carbonate, we just balance it by saying, well, how many carbonates are over here and how many carbonates are over there? Yeah, so the only time you wouldn't be able to do that is like in our copper carbonate example, where it decomposed. Here, we'd have to not do that because there's no carbonate left over here at all. Right? Like the carbonate itself broke apart, but usually radicals stay together, right? Like, and in double displacement reactions, radicals always stay together. So if you have a carbonate on the left, it's going to stay a carbonate on the right. The only thing that's going to change is what it's partnered with. So this is just a way to balance quicker, but if you're uncomfortable with it, if you want to just take a little more time, you could have said, I have C, and you could have said, oh, there's 1 C on the left, 1 C on the right, cool. And then you could have said, oh, there's 3 O's on the left and 3 O's on the right. That's cool. And there's nothing wrong with either way. One isn't better than the other. I do it this way because that's just the way my brain goes. But if you prefer the other way, don't be shy. Sorry? Take your time. Take your time. There's no rush. And don't just blindly write. I would say, too, that's the whole lesson. We're going to do 2 more examples, but that is the whole lesson. That's it. Except for one other little piece. Now, you should have done double displacement as well in grade 10, though that's probably a long time ago. 18 years ago. Hannah was the ripe old age of -2.
Oh, yeah.
Hannah, a bigger believer in reincarnation, knows that in her previous life she studied this.
I was actually a scientist in my previous life.
I believe it.
And I was friends with Big Guns to the Rocks.
Well, that's true in this life too, I'm sure.
I have pencils
I love it.
Sorry,
Okay.
later.
Okay. Hundreds. Which I don't know what it says about me, but like, first of all, let me say, and this isn't like, I'm not using reverse psychology or anything here. Don't ever spend money. It's stupid. I get paid to be here. So don't buy me things. That's dumb. Don't buy me a Christmas gift. Just, say, hey, Orlando, Merry Christmas, idiot. And I'll be like, thank you. And we can move on. But honestly, I will say from time to time, people buy me gifts, which again, I don't encourage. I get paid to be here. But when they do, it's always very sweet and I appreciate it. But I don't know what it says about my personality that inevitably it's just coffee mugs. That's always what people buy me, which is nice. I love having them and I really like my collection of coffee mugs. But it is like, am I so boring that that's like the only part of my personality people can think of? Oh, I like that. I love that. So do you have a bunch? Oh, I love it. Do you have a favorite? No? You love them all. They're like chids. You don't have a favorite. Charlie.
When you're all like, when you're over like 80 years old, you tell your grandkids, oh, this one was back in the
No, but can I tell you, that is, when my grandparents passed away, I just have a couple of things from them. They had a lot of stuff in their house, but I thought I have a small house, I don't have room for junk. I can't have everything. But I used to go with my grandfather and he collected clocks. It became an obsession. For a while, he had like 150 clocks in his house. He had a big house, but still. And for a while, he used to keep them all running with the chimes going. And on the hour, it would sound like the nuclear apocalypse was going through my grandfather's house. But he used to have to go around and wind them all. And some had to be wound every day. And some had to be wound once a week. And some had to be wound once a month. And he had one that you wound only once a year, which he would always let me do. But so I used to, when I would stay over at his house, which I stayed over like at least once a week, usually a few times a week as a kid, we'd go around and we'd wind all his clocks together. And he had a book that he'd keep track of when he had to do them. And so when he passed away, I got one of his clocks, one of my favorite ones, which is a really plain one. Like he had some really fancy ones, but there's this one that I always really liked that was very simple. And I got that magnifying glass that I keep here because that was on his desk in his office. And then I got a bust, like a little statue of Abraham Lincoln. And these are like the three things I keep from my grandpa. And they're really special to me. Like they're not like super fancy things. But so like having stuff like that you collected your whole life and you do talk to your grandkids or your kids about, those will be really special things to them one day. So like my collection of coffee mugs, I probably would have lost them all by then. Yeah, go ahead.
So for me, when my grandma passed away, she had this like huge. Why I started collecting snow globes
Yeah.
was from her.
Oh, I love it.
Because whenever I was little, I would always like grab one and shake it.
Oh, I love
and,
it.
Make a wish in it.
So how cool is that? So that's like that's like passed through like 3 generations already.
So
That's really cool.
I have this huge like collection.
Oh, I love it.
Before she passed away, my cousin like handed me a snow globe and said that your grandma wanted you to have this, but she saved it. So then when I got older, then
Yeah.
she gave it to me.
That is really cool. Yeah, so you wouldn't like wreck it as a little kid, right?
And then I also got this like teacup thing from her.
I love it.
Yeah, and it's like teal blue.
Oh,
It's so
beauty.
weird. It's like weirdly shaped, but it's like an old fashioned one.
That's
which
so
is
cool.
Really cool.
Yeah.
And
So yeah.
in my nana's apartment, she has like this like one cupboard and it has like just tea cups and all the old ones and all that.
Oh, I love it. Yeah, I did get my grandmother's set of fancy teaspoons, the one she used on special occasions. I gave that to my daughter, so she has Grammy's collection of like nice fancy teaspoons. And every once in a while, we have a little tea party and we use Grammy's spoons. Yeah, like little things like that are really special. So I encourage you to collect useless junk because one day your kids will either throw it out and go, "Oh my God, why do you keep all this stuff?" But there'll be like 1 or 2 things in the mix where they go like, "Oh, that makes me think of."
Either that or depending how antique they'll sell.
Yeah, which, hey, that's good too. If my kids can sell something of mine, make some money, more power to them. Let's try another one. Let's try calcium nitrate, and I'll give you the formula. Plus, let's do copper 1 chloride. All right, so this is calcium nitrate. I'll even give you the names because I'm a nice guy. And this is copper 1 chloride. And I want you to show me how those will react. Well, if you want to know, I'll even give you all the charges. Nitrate takes a charge of -1. Calcium, you can probably figure it out here. If each nitrate is only taking 1 electron, and it took 2 of them to handle calcium, how many electrons is calcium giving away? Also, we could just look at the periodic table. How many electrons does calcium give away? It gives away 2, that's right. Copper, 1, well, it's right in the name. How many electrons is it going to give away? 1. And chloride is going to take 1. So when they switch partners, you can figure it out from there. You can do this. Take 2 minutes. Figure it out. This is a really good cup of coffee.
Like 2 days after that, I was like 3 months till I'm done. I have an early birthday. That was a great tool.
I'm a grade 12.
Damn. Hey, that's good. Hey, she actually thought I was in grade 12. Usually people think I'm in grade 9 or grade 10.
No, I get.
Oh, we're technically in the same age. We're technically the same age. It's only a 3 month difference.
Yeah.
And
My birthday's.
like my sister, 9. Like technically it's 3 years, but I'm saying 9. It's literally because she's born December 23rd and I'm January 13th, right? So it's only like literally weeks until it's 2 years. Trust me, until you can walk on water.
Right?
Until you can walk on water, come talk to me. Until you can spread the seas, come talk to me. Not
It's 9/11.
look at that terrorist.
You always laugh at anytime you see somebody driving away. You know.
Did you just get it?
Always do every time.
No, I had this friend. I had these 2 friends, and on every time at 9/11 or whatever, he would text my other friend and say, "Yo," or just as a joke, as it her face, that she was black. So and he's like, "Oh yo, 9/11 or something like that." Like every time he has to. I have these.
Period.
Oh, you just. I don't know if you can know I'm struggling or not.
By only. Yeah, it's kind of strange. Help me. Help me. Yeah, probably so. Elijah.
Why did I'm generally struggling. Help me.
All right, how we doing? What do we got? Talk to me. Talk to me. Okay. So, these things are going to swap partners. That's what we call a double displacement reaction. Which means calcium was partners with what in the first case? Nitrate. What's it going to be partners with over here? Calcium is now going to be with chlorine, right? And we call that calcium chloride. And copper was with chlorine. Now it's going to be with, what's it going to be with now? Nitrate. I find it helpful to actually come up with the names first. Am I the bro? Okay, just checking. It's fine if I am. Makes me feel very youthful if somebody your age is calling me bro.
I never, the age difference could be crazy though. It's like 25.
Right? That's what I'm saying.
30.
Okay, not 30. Settle down.
Let's not talk about the age thing again.
It's fine, we can talk about the age thing, but I'm not 45. I'm 40. No, my feelings don't get hurt. Truth is, no, I'm an old man.
You're 40.
Yeah.
Yeah, right? I didn't.
See, that's what I'm saying. Okay, so calcium chloride. Now, once you've got the names, then you have to figure out the formulas. Shh. And when you find the formulas, what do you have to do? You got to do the hard work, right? You can't just say, okay, CaCl, you got to do the work. What charge does calcium like to take? You can look up there. How many electrons does it want to give away? I mean, I put it here, but +2. Chlorine, how many electrons does it like to take? 1. So, the first calcium is going to give away 2 electrons, but the first chlorine can only take 1. What do we need more of? Do we need more calcium here? No. What do we need more of? Chlorine. Because now when we have 2 chlorines, they'll be able to take 2 electrons. So what's the formula of calcium chloride? Very good. And copper nitrate, copper 1 nitrate. Copper, how many electrons in this case does it like to give away? 1, very good. We know that because it's called copper 1. It could have been copper 2. Nitrate is, well, we see it over here. What's its formula? NO3. And how many electrons does nitrate want to take? 1. So in this case, the first copper gives away an electron, the first nitrate takes it. What's the formula of copper nitrate? Yeah, nice and loud. Very good. All right, and we're good. What's the only thing we need to do with this? We need to balance it. Okay. Let's go. Left side, right side. Legally insane. That's better than going illegally insane, I guess. It's good to know that you're not breaking any laws as you go insane.
I wouldn't want that.
No, you want to be a law-abiding crazy person, just like Joe. Okay, let's start with calcium. How many calciums on the left? Cool. How many calciums on the right? All right, so far so good. How many nitrates, NO3s, the whole thing on the left? 2. How many nitrates on the right? 1. Can we fix that right now? What do I need to put in here to fix that?
2.
Where?
Before the down formula.
Yeah, that's right. Before the copper nitrate formula, right? We need 2 of those. Okay, that means I have 2 nitrates now, which is good. Let's keep going. How many coppers do I have on the left?
1.
How many coppers do I have on the right? Can we fix that right now?
Yep.
How do I do it?
Put a number 2 before
Which formula?
the copper one for
Beautiful. Yep, very good. And that means I have 2 coppers now, which is good. How many chlorines do I have on the left? 2. How many chlorines do I have on the right?
2.
Good. So that means this thing is balanced. We're good. How's that feel? Not too bad? All right. You okay? I won't. Okay. I'm going to post your next lab. You can also get some practice with this. Of course, where do we practice everything? Yeah, if you go and don't worry, this will come back. It's not going to go anywhere. Settled in. Yeah, if you go to Power Apps and go to the Practice app, the section on reactions, you can set it to double displacement reaction. It'll give you double displacement reactions all day. That's a good starting point. I'm trying to remember, there should be an option where it gives you the name or where you have to figure out the name. Let's see if that's true. So if I went to chemistry, I went to Chem Practice V2, very cleverly named. Look at that symbol, isn't that lovely? Very chemical, right? Oh, it's been doing this lately where it breaks my allow. All right, so if we go reactions, we could go just double displacement. And you can see here in double displacement, you have the option. If you want to make it a little more challenging, you can have it give you the names. Or to make your life a little easier, you can just have it give you the formulas. Do you see that? So let's try this one here. Okay. This is iron 3 chloride. And this is lead 2 nitrate. If these react, what's going to end up with what? So iron was with chlorine. And this, by the way, is the +3 iron, and that's -1 chlorine. And lead, which was +2, is with nitrate, which is -1. Iron's going to end up with what? Nitrate. Good. And so when iron, which wants to give away 3 electrons, ends up with nitrate, which wants to take how many? 1. If we have 1 of each, does that work? Iron wants to give away 3 electrons. Nitrate can only take 1. What do we need more of? Do I need more iron at this point? No, I need more nitrate. So 2 nitrates would take 2 electrons. Does that work? No. So we need 1 more. The 3rd nitrate would be good. So we're going to get Fe and then NO3, 3, just like that, which looks perfect. Brackets is correct. Oh, you guys are good. In time, you could be great. Okay. And then lead is going to end up with what? Lead wants to give away 2 electrons, and its new partner is chlorine. And how many electrons does chlorine want to take? 1. So the first lead gives away 2 electrons. The chlorine can only take 1. Do I need more lead?
No.
Do I need more chlorine?
Yes.
Yeah, 2 of them will take 2 electrons. What's the formula of lead chloride? Very good. And then from there, that was FeNO3 and PbCl2. Okay. Are we balanced? How many irons on the left so far? One. How many irons on the right so far? Good, we're good. How many chlorines on the left? How many chlorines on the right? Damn, where do we have to meet at 3 and 2? You got to meet at 6. What number in front of here makes this 6? 2. What number in front of here makes this 6? 3. Uh-oh, we're screwed up now. How many irons do I have? So I only had 1 here. What do I need to put in front? Then it wouldn't match, right? 3 irons and 2 irons doesn't match. 2. Good. So now we have 2 irons, 2 irons, 6 chlorines and 6 chlorines. So far, so good. How many leads do I have here? How many leads do I have here? Damn it, what do I have to put here? Okay. And how many nitrates do I have here? Careful, each one of these has 2, but I have 3 of them total for a total of 6. And how many nitrates do I have here?
6.
Yeah, because each one has 3, but I have 2 of them for a total of 6. That should be good. Or it won't be. Let's find out. Hey, does that make sense? You can do that all day. All right? If you want to, you can send me a message. I always like when I get a message. And by the way, if you're getting them all right and you want to be braggy, hey, Orlando, I'm so smart, send me a message. That's cool. When do I really want you to send me a message? If you're getting them all wrong, send me that, because not only can I see that you're struggling, but I will actually see what you're doing, and I can go like, oh, I see what you're doing. I know the mistake you're making. And then you know what I can do? I can help you, but I can't help you if you don't talk to me, right? Okay. The other thing I'm posting is your next lab prep. We're going to do a lab on Thursday, lab 2.2. What about your head? What can't you do? Oh, your hand is killing you. Okay, I'm done. So you don't, please don't let. Okay. Anyway. Okay. 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 Shh. Shh. We have one. No. What did I write here? That was very. It's very emotional response to that. I was like, no. I'm so upset. Okay. I'm sorry. I don't know why that was so. I just couldn't contain myself. There is one more element to this, when they happen and when they don't. When do single displacement reactions happen again? Remind me. Something will be able to kick something else out if it is more reactive. And if we're looking at like an activity series, a list like this, that means the thing that's trying to do the kicking out has to be where on the list? Higher, that's right. That's not how double displacement reactions work. Because of course, if Gary is kicking Larry out, and Larry is also kicking Gary out, right? So it's different. It has a different rule. We're going to learn about that actually when we do our lab on double displacement reactions. We're going to investigate how we know when one happens versus when one doesn't. But yeah, if you want to, I didn't mark your last labs because I forgot to take them home. They're sitting there in a stack and I meant to take them home. That's okay. If you want to take it home and prep it, you can give it back to me tomorrow and I'll mark it. If you want to leave it with me, that's fine. I'll mark the ones I have tonight and then you can prep it tomorrow. But if you want to get this prepped so you're done with it, this is also a pretty simple experiment. It's actually going to be run by Caitlin Hempel. She's going to run this lab. Yeah, no, I told her. I didn't even tell her. I asked her. I didn't foist it upon her. I wouldn't do that. I do that to Tatiana. I wouldn't do that to Caitlin. Tatiana has earned my ire, but not Caitlin. She's done nothing to earn my a pop lab. I don't think I'm gonna do any pop labs. I'm nice. Those things people know. That's what I was just checking. Good, you remember.
Oh yeah, I definitely remember.
Okay, whoa, don't pack it up then. I'm not doing that. Make yourself useful. You got 3 minutes.
Why did I get time to
Sorry?
Why did I get time to
Yeah.
You did.
I had like a day, not even. You told me 4th period the day before. And then didn't send me the information.
Yeah, and you did great.